Okay, last video in chapter 6, and we are proceeding with our chapter review. Problem 1, look at the triangle ABC, fill in the blanks, right? So here is our triangle, and they ask us for the height AD, right? This is our AD, right? What is the base? We know that the height is a line that is go perpendicular to the base. So what is the base? That is the base, right? So we write it CB or BC, doesn't matter how we call it, right? Looking at the same figure for the base AB. Now they ask us to calculate the base, not the calculate, but for the base AB. This is the base AB, right? This is the base AB, and there are two basically confusing options, but again we extrapolate this line, right? And we make a perpendicular line, right? So this will be the height, right? So the height is CE or EC, doesn't matter, right? CE. All right, good. Gonna erase that thing. Next one. Number 2, find the area of each shaded triangle, right? Okay. Very easy, right? So triangle is half of rectangle, so we calculate the rectangle, right? Here is the side is 16, here the side is 12. So the area of triangle is 16 times 12 times 1/2, right? Calculate, do your math, which is what, 96 square centimeters, right? Now triangle B, right? This is your base. This is your base. This is the perpendicular line, which is height, right? The height is 13 meters. The base is 28. We need half of the product, right? So 13 times 28 times 2, right? 182 meters squared. All right. Problem number 3. All right. The figure ABCD is made up of a rectangle BCF, triangles AFD, that's this triangle, right? And triangle FED, this triangle, FED. Okay, again, one rectangle, one triangle, one triangle. All right, clear. And they give us different shapes. Oh, sorry, different sides, right? Side DE is 7 centimeters. All right, you can read everything, right? So basically, we need to find 3 different areas, and we need to sum up, right? Sum up. Okay, let's check it out. So the first one we consider rectangle BCF, right? BCF has which sides? He has a side of 10 centimeters, right? 10 centimeters, and the side of 3 centimeters, right? So we write it. The area is, we multiply, right? 30 centimeters squared. Okay, next one. We consider triangle AFD, which is this one, right? This triangle AFD. Here is the base, right? How do we find the base? The base is 8 centimeters, like the whole thing, minus this 3, right? So the base is 5. And we know the height if we extrapolate it like this, and the height is 10 centimeters, right? This height is 10 centimeters, the base is 5, right? Triangle AFD is 5 times 10 times 1/2, right? It's gonna be 25 square centimeters. Lastly, I'm gonna write this thing. We consider FED, triangle FED. Yeah. What do we do here? We have our base and we have our height, right? Well, because it's a right triangle, it doesn't matter. Both can be, like, they can switch. One will be height, one will be base, right? So we multiply them, 7 and 10. 10, and 7, right? And we find our, okay, FED area. FED area is what? 7 times 10 times 1 over 2, right? 35 square centimeter. All right, what is the answer? You sum up all these three areas, all the areas of these three figures, and you got your answer, right? Which is what? 25, 35, 30, 90 centimeters square. That's your answer. Okay, can I erase this thing? Last problem in the figure EFGH, right? Okay, what do we have here? We basically thinking about this, so we need to find this green shaded area. All right, this is what we do. We split up like this, right? So now we have this one triangle, and so triangle GHE, right? And GHE triangle, and triangle EGF, right? EGF. So now let's consider the triangle EHG. Right, we have our height, right, 5 centimeters. We have our base. Our base is 2 centimeters and 1 over 2, right? It's gonna be 5, right? 5, what is it? Centimeters square centimeters. Okay, and now we consider the second triangle EGF, right? We consider this triangle, and we have our height, because you can see this little symbol, right? This height is the same. So EG, and they tell us EH and EG are 5 centimeters. So this height is 5 centimeters, 5, and this is 4. The base is 4. So 5 times 4 times 1 over 2, right? 10 centimeters squared. Now we found our two triangles, 1 and 2, right? We put them all together. The answer is 5 plus 10, 15 square centimeters. Okay, chapter wrap up, right? Please take your time, read it through. But the whole chapter area of triangle is about three main concepts: base and height, right? Base and height. Where is my pen? Base and height. We need to learn to identify. So base, it can be basically any side of the triangle, and the height is the line that goes perpendicular, right, from one of the vertex into onto the base. That's the concept number one. Now concept number two, we can find the area, right? And we need to memorize the formula. If we know how to identify the height and the base, then the area of the triangle is a product of height and base. It's basically half of product, right? So we need to multiply by 2, right? Or, otherwise, we can think of it as a part of a rectangle, as a picture right here, right? Half of the rectangle is the area of the triangle, and this is what they say here. And the last concept, but not the least, composite figures, right? They tell us that any complex figure like this can be broken down and it can be into parts, right? So this is what they did. You can break it, the complex figure, into simple parts, and you will have your simple shapes like rectangle and like a triangle. All right, that's the whole thing. And then you calculate their areas separately. You sum up the areas and you can find the area of a composite figure. All right. Okay, the last page of the chapter. This chapter was very short. 3 problems. Put on your thinking cap. All right, so problem number 1. They give you 2 triangles. They kind of overlap partially over here in this area, right? And they ask you So you will read, right? They ask you to find the difference in the areas of the shaded parts, right? Shaded parts. Okay. So this is what you do basically, right? It doesn't matter that they lie like this on each other, overlap in an awkward manner. It doesn't matter, right? You have one triangle, you have triangle ABC, right? This triangle, and you have triangle DEF, DEF, right? You have this triangle, and it doesn't matter that they overlap like this. You can think of them about two separate triangles, and you just need to calculate the difference between their areas, right? So the triangle ABC, we identify our base, so our base is 10, our height is 8, or vice versa, because it's a right triangle, right? So it's the half of the product is the area, right? Which is 40 square centimeters, right? Next triangle is DF, DF, DF. We know the base, we know the height, same thing. 9 times 12 times 1 over 2. What is it? 54 square centimeters. Now what is the difference? 54 minus 40, 54 minus 40, 14 square centimeters. Easy. Number 2. Haley wants to cut the following triangle from a piece of paper measuring 42 centimeters by 30 centimeters, right? So you can imagine the big piece of paper, right? It's a rectangle, right? 42 is the length and 30 is the breadth or width. What is the most number of triangles she can count from the paper, right? So we need to find this area, we need to find this area, we need to find how many these kind of pieces can be inside, right? And this is what we do, right? Area of this one is 4 times 3 divided by 2, right? 4 times 3 and 1 over 2, right? So it is what? 6 square centimeters, right? 6 square centimeters is the area of this yellow triangle, right? And now we need to find this area too, right? So the area of the rectangle is just simply 42 times 30. Okay, so 42 times 30 is 1,260 square centimeters. Well, something is odd, right? We cannot just divide the area. So it makes us think, what do we need to do? We need to do this is a question asking us about our understanding of the concept of related rectangle, right? So how many rectangles, if we think of it, how many these small rectangles we can place them inside, right? So yeah, definitely, like here, over here, if this base of the triangle is 3 centimeters and the piece of paper is 30 centimeters, obviously we can place 10 pieces like this, right? So this will be 10 over here, right? So there will be 5, 1, 2, 3, 4, 5, right? Like this, 5, right? But if we will start to place this rectangle, related rectangle, right, vertically, and try to see how many will fit here, we will see that only until 40 centimeters we will fill them up, right? We will make like 10 of them, but then after we will have this 2 centimeters and we cannot fit another rectangle, right? So actually our available area is just 40 by 30, 40 by 30, right? This is the available area, and this 2 centimeters gap over here, like 2 centimeters, it's not available for us. We cannot place this rectangle inside, right? So now we calculate the available area. 40 by 30, 40 times 30, right? and it's gonna be 1200 centimeters, square centimeters. That's the area, available active area, right? And we know that the area of a triangle is 6, right? So we divide to 1200 by 6, and it's gonna be 200. 200 of what? 200 number of triangles. We can make only 200 triangles. Right? Okay. I hope you follow the last problem here. In the figure PQRS, PQ is parallel to SR. Right? PQ is parallel to SR. It means they will never cross each other. Okay. PQ is 12 centimeters, SR is 15, and PT is 10 centimeters. Okay, but all right, they show us right here. So what do? We basically split it up like this, right? And now we have our two small triangles, like these triangles, and we have our rectangle, right? This is what we do. So rectangle 10 and 12. Let's calculate the rectangle first. Right? Rectangle is very easy. Rectangle is what, 10 by 12, right? 120. What is it? Centimeters, square centimeters. Right, now let's think about our triangles. This side is 12, but the big side is 15, right? So if this side is same as 12, we will only have 3 centimeters for this piece and for this piece. So each triangle, the area of each triangle will be 1/2, and 1/2 times, here is the height, right? 10 times, we need to divide 3 centimeters, divide by 2, right? 3/2 centimeters, like this small piece, right? Each triangle, right? Okay, so we can calculate this and we can multiply it by 2, or we can, because we know we have 2 triangles, we can do it right away. 2 triangles, right? We do it by 2, and these numbers will eliminate each other, right? And we will have 10 times 3 divided by 2, 15, right? 15 centimeters squared. So we have 120 rectangle, we have 2 triangles of 15 square centimeters, and if we sum up, 135 square centimeters. That's your answer. Okay, congratulations. We just finished the theory of the Pupil's book, chapter 6. Now work through your workbook, and yeah, over here you can see your workbook part. Put on your thinking cap, on the page 104. Try to do it, and we're gonna discuss it too later. All right, see you.